Good morning and good afternoon to you all joining this webinar. Thank you for taking time out of your busy days to join us today. My name is Nigel Dean and I'm the Marketing Director at Spire Payments, and I'll be your host for today's webinar. The drive behind this initiative is to share our experience within the payments industry. This we hope you will find informative. During the presentation you'll all be muted just to keep it under control. If you have any questions during the presentation, you can use the chat button to actually type in your questions. So just to check this is working, if you go to the right of your screens on the dashboard, you will see the word chat with a small plus to the left. If you click on the plus, you'll see the text box appear, and in that text box you can type a message and send it. So just to make sure it's working, could you type in where you're listening from, what country, and fire it over to me, please? We'll see who's going to be first. Okay, so I've got someone from the UK. That's excellent. Okay. And okay, right, Croatia, Qatar, UAE, wow, South Africa, okay, Bradford, there you go, that's very good, Morocco, Croatia again, Salisbury, but of course Salisbury, so yeah, so that's fantastic. So I think we've got an excellent audience here today. Okay, so today's webinar will be focusing on APIs. Application Programming Interfaces. Now, on the face of it, this may sound a rather technical subject, but APIs are key for the POS and MPOS environments. This was clearly apparent when I presented at MPOS World last week, when there was a lot of questions around this topic. So, let me pass over to Carlos Gomez, Spire Payments Security and Compliance Engineer, who will be our presenter for today. So I'll hand over to Carlos, and at the end of the presentation I will then ask questions that will come in. Thank you very much. Carlos, over to you.
Hi Nigel, thank you. Thank you very much for your kind introduction, and welcome to everyone. This is Carlos Gomez speaking from Spire's Madrid office, and I'm going to talk to you a little bit about application programming interfaces, what they are and what they mean for point of sales terminals. My goal in the chat is not to go into too much technical detail, but to cover what we believe to be the strongest features of an API, what an API should offer for developers, how an API is supposed to be used, and how strongly we believe that the tool chain around using an API is also very important when developing applications. And once we've established that, we will move a little bit towards security aspects of an API and how a strong API, a well-built API and a well-built tool chain can help you provide secure applications in a secure environment for payment processing. So without further ado, we can move on to the first part. Now the first thing is just to give you a brief introduction on what an API is and what it means. An application programming interface is something that will give access to for payment applications access to the underlying functionalities on a terminal. This here on this screen, what we see is an old legacy Spire terminal in which we used to have a payment application, and this payment application would access the underlying processor, CPU, the printer, the card reader, so on and so forth. And in order to do that, in these old embedded systems, you would have to have very strong knowledge of the underlying hardware. You would have to know what the CPU looked like, what it was capable of. You would have to know a lot about the drivers and what they were capable of as well. And also you would end up having some standard libraries that would help you, that would help you access some of the most common functionalities on the device. Obviously, we've come a long way from there. We see that the embedded platforms, the electronics under the hood for these terminals are becoming more and more powerful. Well, you see it every day on your pocket. In your pockets, you have your cell phone that's running on an embedded system that is very much more powerful than computers were 10 years ago, maybe. You see this on the advent of what they call now the Internet of Things, where you have sensors everywhere and everything is interconnected, and everything information sharing is growing and growing. The trouble with this additional power and additional platforms is that you have an exploding ecosystem. You have a lot of different CPUs, you have different interfaces, communication modes, protocols, things like that. So in the end, unless you have an API, something that encapsulates functionality, it's very, very hard to start programming and to bring things to market in a timely way and with good quality. And it's also very hard to just exercise all the potential that these new embedded systems, these new CPUs are providing. So what does this mean in terms of point-of-sale terminals? I mean, point-of-sale terminals are still very close devices, so what we should be bothered or worry about this? Well, basically, because nowadays you're moving from a payment application into a terminal that is running multiple things. It's still processing payments, obviously, it's what its main purpose is. But it's probably also running loyalty applications, things like on-spot advertising, and other minion things like that. So you're running more applications, you have multiplication environments, you have different pieces of code accessing the hardware and different pieces of hardware in the ecosystem. You have countertop terminals, you have things that are mobile, you have retail PIN pads that live on a supermarket checkout line, things like that. So if we keep this old environment where you have the libraries and you had to know a lot about this hardware and the drivers, it's extremely difficult to leverage the power of the new platforms. So obviously what everybody's doing is moving to provide a better encapsulation, a better way of accessing things from a higher level perspective. So you don't have to know whether the processor underneath is an ARM, a Broadcom, or whatever it is, or an Intel PC even. You never know. But all you need to know is that well, there are some ways of accessing functionality, and you can exercise those in whichever way your application needs to access them. Once you have this API over here, then you are no longer worried about what's under the hood. Over here, well, you have some drivers and operating systems, obviously, but you don't need to care so much about those because you're free to develop on a higher level, if you wish. Now, APIs come in different flavors and looks and feels, and not all are the same. Some APIs are very tied up to the hardware still, others are more generic, and without wanting to be canonical, without wanting to establish a golden standard, these are the features we believe a strong API should provide a developer with. We believe an application programming interface should be complete. You shouldn't have to have an API, a very good API for, say, using the Wi-Fi module on a computer, and then nothing at all for the keyboard, so you end up having to run things directly on hardware. We believe that the applications should be able to access all functionality and provide a full user experience without having to go into the details of the platform. And not just the platform, we believe API should be cross-platform as well. The idea here is that you should be able to write an application once, and if you write it properly, you should be able to run it on any platform that you're supposed to address in your market. So if you have a countertop terminal or a mobile or an POS device, even maybe in a glove compartment of a taxi driver, you should still be able to run the same application, only with minor tweaks perhaps. That should be done at the code level, but the API should provide all the functionality that the application needs to provide regardless of the specifics of the platform. In more technical terms, we also believe that the applications, that the APIs should be non-binding, meaning that the API does not show the implementation details, that does not show what's underneath the calls, so that applications can do things in whichever way they like. They are not forced to do certain things in certain ways because the application interface is mandating that this should be done in this and this way. You should be able to freely put together your functionalities to provide an end user experience. And user experience, by this we mean strongest encapsulation as well. An API should not just provide functionality, should not just provide excuse me, should not just provide you with ways of, I don't know, opening the keyboard or accessing the screen or whatever it is, but should encapsulate use cases. For example, going back to the example, if you wanted someone to enter their PIN number, you wouldn't want to have an API that would ask you to first enable the buzzer, then open the keyboard, then do this, do that, etc. You should be able to just use a function that would say something like, please get the encrypted get the encrypted PIN block from the user, and the API should be able to encapsulate the functionality and do whatever it takes with the hardware underneath so that the application in the end receives the result it is expected to. Okay, that's from the functional side. An API, we believe, should also be secure. Secure in the sense that an API should do what it's meant to do when it's used properly, and when it's not used properly or there's some sort of mistake, misuse should not affect the device security or its stability or integrity. It should not reveal sensitive information of any kind, and it should allow applications to handle critical information securely. It should not be the case that when something goes wrong or a call is made in a perhaps not perfect way, the application crashes, and also we start seeing sensitive information all over the place. An API should be easy to use and to learn. Ideally, any developer should be able to just take a look at the API description and say, okay, yeah, I know how to put this together to do whatever it is that the application needs to do, a payment, process a loyalty card, or provide advertising, a QR code, or whatever. The details, of course, will come in the documentation, but at least in principle, the API should provide a human-readable access to the functionality underneath. Once you have functionality and you have an idea on how it works, obviously you need to have documentation. You can't possibly hope of using an API unless it is documented. Obviously, the documentation can come in many forms and manners. It doesn't need to be a stack of papers. It could be help files. It can come through training. It could come through support centers, things like that. But we believe that documentation and information is as vital as the API itself. It's just part of it. And lastly, obviously, an API needs to be public. What would be the sense of putting an API together if we were just going to use it internally in our organization? In our opinion, our API, and in our view, what we do is the API we use internally for development, in those cases where we develop things, is the exact same as those available to our third-party partners. We strongly believe that the only way to provide a strong user experience is by leveraging all knowledge and making it available to partners. Okay, but an API, however, it's as strong as it may be, is only half of the story. You still need to use the API, and this is a bit of a simile. You still need to cook your application. And what would you rather cook? Would you rather cook here on the left-hand side, on this kitchen that looks a bit like I've just cooked something in it, or would you rather do it on this rather nice, big, ample, shiny new kitchen when you can even actually have friends over for dinner? Well, basically, obviously, the SDK, the software development kit, is the bunch of tools, the set of tools that come with the API and will allow you to use it. Compilers, linkers, debuggers, the programming environments, if you wish, codes with code tagging, things like that. So the API will be the ingredients, and your SDK needs to be the kitchen, and there you will cook your application with whatever recipe that you need to provide to the market. So we've established that APIs and SDKs are important, obviously. This is something that occurred to me when I was putting together this webinar. I was thinking, well, this is all too obvious. I mean, who wouldn't take the quality and capabilities of an SDK and an API when you're deciding what platform to use. It may not be the only decision point, obviously, because other things, cost and other matters may come into play as well. But I think it's common sense that you would have an API and the SDK into account. And yet, how many of us have had to build and integrate our own toolchain because what we were provided by the vendor was not a very good toolchain? It has happened to me. If any of you out there have ever done some development, you've seen this. You end up having to provide your own scripts and integration, and even sometimes integrate a third-party debugger because the things that you're provided with just do not work. And this is not just because we, the techie guys, like to live in a happy place, but because in the end, the environment in which you put things together, like your kitchen, is going to affect the quality of what you cook. It's going to affect time to market, and we're going to make support much more difficult in terms of timing, in terms of finding what the problem actually is, and so on and so forth. All right, we've established then that APIs and the software development kits are an important thing to take into account, and they should be strong and provide a good environment. Let's talk about security for a minute here. Is there really a need for a secure API nowadays in payment systems? I mean, after all, we already have for quite a few years the security evaluation of point of interaction terminals. PCI PTS takes care of that. But is there any additional need for any other security here? Well, if you think about it, in the last couple of years, what we've seen is that the biggest card thefts we've seen in the market do not happen here at the terminal, but rather here at the point of sales or electronic cash register. We've heard the horror stories in Target, Neiman Marcus, Home Depot. We've seen them all. We've seen what happens when applications do not handle data securely and do not provide sensitive data to entities who should not have it in the first place. So that's why we believe it's not just a matter of the PIN being secure here at the terminal, but also the terminal providing only what it needs to provide to the external entities and protecting things through its API. In that regard, surely we need the API to be secure and the application to be secure. So here we are again. This is our terminal. What does this secure application actually mean? What do we mean by all this? Well, we used to have one single payment application, so running on our old hardware, old school hardware with old school libraries and drivers and things, and sensitive card data would go all the way up to the payment application. When you had one single application on the terminal, maybe this is all right, but now you have multiple applications and you need to connect these terminals with more and more complex systems, so here comes a problem. You have nowadays not just one terminal, you have multiple terminals in multiple environments. These terminals are all different in that they live, for example, on a supermarket's checkout line. This one is a handheld mobile device, or maybe this is in one of our restaurants or whatever it is. Maybe we have MPOS devices as well that we use in taxi services or other micro merchant environments, or as support for checkout lines as well. They all running on the same API, and they all have access to card data. So yes, what we need to make sure is that this new layer of abstraction we've added does not just encapsulate the functionalities down here, but also ensures that whatever data is coming through the API and to the applications is what it needs to be, and that applications do have the means and tools to make sure that data is properly protected. But what is a secure application? In reality, is it secure application mean that having a secure application means that it doesn't have to do all it's supposed to, that you need to somehow restrict its functionality? Does it mean that you need to have some additional management processes and procedures just for the application to be secure? What does it all mean? Well, again, without wanting to be canonical about it, but our impression is that a secure application is first of all a functional application. A long time ago, when I was in university, I used to have teachers that would say things like, when you define software, you have your functional requirements, and then you have non-functional requirements such as security. Well, obviously, in our view, this is absolutely wrong, and in particular in point of sales terminals. Security must be a functionality of your application. This is not just a nice add-on, a nice thing to add once the application is built, but should be part of the functional requirements. And you should know and understand what sort of security you need to provide. Maybe it's not much if you're not doing anything with data, with sensitive data. You're just showing images in the screen, or maybe it's a lot because you're doing payments and mixing tokens with card data and all the bits and pieces. So an application must be functional as well as secure. It must deal with sensitive data with care, obviously. It should not store things they don't need to store, and should not keep the things in the clear so that other people can steal them. Crucially, it should not provide sensitive data to untrusted third parties. The example we've seen a couple of slides ago about card data being present on an electronic cash register pretty much speaks for itself. And it should also not provide insecure interfaces. Obviously, when you're building an application, you need to think what your use cases are going to be and how people and machines are going to access your application. So, yeah, you need to take into account that those interfaces need to be secure. And last but not least, we very rarely talk about these things because we don't like to think that our applications and our things fail. It's an inescapable fact of life that applications will crash, just like any other thing, like any other computer. There will be a time and a moment where you have no other option but to reach for the reset button. The whole point of security is when something, it's not that something does not fail, but when it fails gracefully. So an application crash does not compromise the security of the device or its data. Okay, so that's a secure application. Does that mean that now that we have a secure and strong API, we're home free, we have nothing else to do? Is secure API the same as a secure application? Well, obviously not. You can have very strong foundations like you have here. This house is built on rock, but it's built in a pretty edgy place, I would say. It's pretty much on the edge of a cliff. It's taking things to the very limit. I'm not saying it's not secure, but frankly, I don't know if I would like to live there. It sounds dangerous. So probably you want to move from this house over here to this very nice tall tower on the right, where you have also a stone strong foundations and a very nice tall building built on even ground. How do you do this? It's not just with a secure API. The secure API is part of the system, but you need other things as well. First of all, you need a secure platform. Obviously, when it comes to payment terminals, secure platforms are usually secure because they're being certified and evaluated for standards. But not all standards are born the same. The latest security standards, PCI 3, PCI 4, tend to put more emphasis on the software side of things and are better suited for providing a secure environment. Obviously, that platform then has to run an operating system and an API, and that API needs to provide the security ultimately, but a secure platform is the first step towards a secure application. You need to understand what the life cycle of your application is. You need to understand that what your use cases are, what the blocks of the application are and functionalities need to be, and which of those blocks really need access to sensitive data. Again, if I have an application that is doing both on-spot advertising and payment transaction all together, probably the module that is doing QR codes generation does not really need to have access to card data. So that's something we need to take into account. Once you've identified your blocks, you need to start developing on it. Excuse me. You need to start development, and there are sets of well-known, well-established best practices, development best practices in the industry. Spire Payments has actually contributed significantly to one of the latest PCI SSC documents about development best practices when it comes to payment applications running on terminals. But this is all very nice. I mean, you have your strong API, you have your secure platform, you understand what your application looks like, and well, you've set an environment and a methodology that you think will provide the security to the application. It all boils down, though, to the human factor. Training is extremely important. Most people in security have started talking about technical security, and we always talk about technical security, but we realize that the human element is the one that introduces the bugs and the vulnerabilities in the applications. They are the ones banging away on the keyboard trying to put things together fast for the market. So it's very, very important that whoever is doing the programming understands what it needs to do in terms of security. How do we do this internally? Do we actually follow all these, or is this just a nice layer of smoke that we put out so that people do not see what we do internally? Well, basically, we do take this very, very seriously. We do develop platform software for our terminals, obviously, and a strong, what we believe to be a strong API. We also provide some applications in some markets. So our goal is to always provide secure code. And secure code is built around these 4 building blocks. You have, obviously, you need to have configuration management to understand your functionality, what it needs to be, how it is configured, how versions are treated. You need to test and review your code and make sure that anything that goes out there has been reviewed, and the release process is very strong in this. Obviously, you're not going to write, and we are not going to write all the code that goes into our terminals. We're very happy and very proud to integrate third-party software. Most of it is open source, or well, actually all of it is open source, because we strongly believe that security must come through transparency, that the best security is achieved by not by hiding details, but by allowing the community to fix what's wrong and quickly deploying fixes for any possible holes that they could be. So we have a strong culture of vulnerability management and keeping things up to date. But the most important thing that we do internally is guidance and training. That's our view. Obviously, this does not mean every 6 months we put all the software guys and all the developers together in a room, and we give them a talk for 2 hours, they look bored, and then they go away to the desks to do whatever it is that we're doing in the first place. What we do is, for every project and every module that we develop, we appoint what we call a security apostle, someone usually from the security and compliance team, who's not part of the development team, who's not the boss of the developers, does not have any command and control over them, but has an advisory and design support role. Basically, he will sit down with developers and ask them and try to understand what they're trying to do and try to provide the pointers and how things should be done so that things become secure. What we've seen over the years, our experience is that the security apostle will be extremely busy at the beginning of a project, and then as the project goes by, he will become extremely bored. He will have nothing to do because our guys will already know what to do in terms of security and will be very, very aware that what the decisions need to be and how they need to fix things if they need fixing. And that's what we do. The thing is, okay, it's very nice talking about what the platform software looks like, but do we actually enable you to build secure applications? Our opinion, obviously, is that yes, we provide a strong API, we provide a strong environment and a very good SDK to enable people to build secure applications, but we go one step further because the API is strong and we believe the SDK is very nice as well, and you can base a secure application on it. But we believe the stronger points is that we provide a strong security guidance in forms of documentation, training. We provide very detailed security guidance, not just what we are mandated by the standards, but what we believe is really necessary to provide secure applications. And through the partner support, we have a very quick, a very agile channel to liaise and talk to our partners, not just about functional issues and bugs they could find, but also simple consultancy requests, things like, how am I supposed to protect this and this and this? We do that very, very often. Okay, I think that's all from me. Yes. So if you guys have any questions, I'm sure maybe if you've already written them on the question window, I'm free to take them. Hope I can give you an answer, and there you have the details of my colleague Nigel in case you have additional questions later.
Okay, thank you, Carlos. That was very interesting. Now, we've received quite a lot of questions here, and we haven't got time to answer them all. So what I'm going to do is I'm just going to pick a couple because I'm conscious of time. And as Carlos said, what I can do is if you want to ask more questions after the event, just send them to my email and we'll get back to you. So the first question is, does an API assist in contactless approvals? Okay, Carlos, if you could answer that, that'd be great.
Oh, yes, of course. Well, an API, as I said, should encapsulate not just functionalities, but use cases. So an API should be able to not just help you in contactless certifications or evaluations, but provide a nice, simple way to say, okay, please perform a transaction, a contactless transaction with this type of card, whatever it is. In particular, in our API, we provide a fully functional, already certified contactless kernel set for ExpressPay, PayWave, and PayPass. And also, in order to provide the encapsulation that is required, we provide what we call a level 3 layer that hides the functionalities of the kernels and focuses on the transaction requirements.
Okay, thank you, Carlos. Another question's come in. What experience do developers need to use an API?
Well, okay, it's hard to give a generic answer to this question because, well, APIs are written in different languages and come from different places. Basically, obviously, a software developer should be proficient in their job. They should know their languages and they should know their standard libraries. But other than that, as we said, a strong API should be pick and play. You should be able to pick up the header or definition files of the API, have a look through them and say, yeah, I think I have an idea how we can put this thing together to do a transaction or encrypt these or show an image on the screen. I don't think there's any specific additional experience requirement other than being a sensible and proficient programmer.
Okay, excellent, excellent. Right, another question. Could you please provide more information on why APIs should be used? Why should we want to use them? And what can be reached with APIs compared to current interfaces?
Okay. Well, if you keep an eye on this picture that I'm showing now, if you compare this with a simple, say, a personal computer, you would have your underlying operating system with the kernel system calls, and you would have your POSIX and standard C libraries. Obviously, there's nothing from stopping you doing something like this, but first of all, point-of-sale terminals do not provide full access to all the hardware and capabilities underneath. Obviously, there needs to be some protection for sensitive information like cryptographic keys and PIN information and things like that. But not only that, but there will be little point on writing something on a proprietary platform. Perhaps when it comes to our platform, it's not so important because you have a Linux kernel underneath. So basically, it's the same as if you install Linux on a PC and start writing code for it. With the limitations, obviously, that you will not have a 23-inch plasma screen to visualize things when it comes to the terminal. But the API is going to abstract all the details on how things are done internally. It wouldn't really make much sense to reinvent the wheel every time you change the platform, or you're doing things instead of for a mobile device, you're doing it now for a countertop device or things like that. I think it provides, it's very important, and also sorry, it's in a sense, it's future-proof in that if tomorrow we decide that we're not using Linux anymore, but Windows CE or whatever strange thing we might decide to use, the API will remain the same. So if your application is written using the API, porting it should be easy. If you wrote things or using primitives from an operating system or a hardware microcontroller, then time to market and debugging is going to be much more difficult.
Excellent. Okay, Carlos. Now, I've got a lot more questions, but we're running out of time here. There's one question I can answer, actually. A few people have asked, will the webinar be available? And yes, it will. It will be available on our website in the next few days. We've also got some documents which you can actually download, some handouts. So if you look at your control panel on the right, you will see handouts 3 of 5. So if you click on the plus, you can download those documents, which are explaining our SDK and our products. In addition, you can go to our website, obviously www.spirepayments.com. I think what I'd like to say now is thank you to you all for listening to this webinar, and thank you very much, Carlos, for that fascinating presentation.
You're welcome.
And again, if you have any questions, if you could just email them to me with the email that's on the screen, that would be superb. I'd just like to finally say this is the first webinar of a series we're actually planning. So watch your emails for the next topic